Hi, welcome back. So we are at the last outline of section 2, the philosophy of descriptive and inferential in chapter 1, research in principle. In this outline, we're going to explore the definition and visualize the meaning of inferential and generalization. To do so, there are two terminologies that we have to start up with, and that's representative then generalization. So let me share with you the following example. In definition, representative, it means typical of class, group, or body opinion. Another definition, something that containing typical examples of many or all types. Now, what I am interested in is to see what is the common vocabulary that happens to be between these two definitions. Typical, so typical of class, group, or typical examples. Technically speaking, from mathematical perspective, typical represent in the world of probability or statistic the average. It represents something that you expect. As something happens to be carrying characteristic, and it seems to be those characteristics are the popular one around a group. Now, let's go and visualize this. Assuming that I have this big circle. Now, inside this big circle, let's assume there are a number of elements of any kind. Just I would try to draw them like so. This is the all. Let's see, for example, if I want to look at any of those elements, I'll take this element. Now, I could look at this element in many different ways, and each one of us would look at it. Depends on from which perspective you are seeing it. I will assume that I want to see this element in terms of two characteristics. The first one is X, the second one is Y. Now, to be much more natural in speaking, I could look at this element in terms of age and gender, education, and background. But anyway, what is the possible values that X and Y can take? For example, if I take X alone here, X values could be 0, could be 1, 2, 3, or 4. And for example, Y take values between 150 all the way to 190. All right. So what happened now, if I pick this element here, and I look at its value, it happens to be 3 and 151. Now, if I pick another element, happens to be this one here, maybe I measure and I found it's 4 and it is 159. And keep doing so. What do you see in general? That I was able to explore each and every element within this all in terms of the value of X and Y. Now, if I assume I would have had 100 total of those white dots, I have measured all their X and all their Y. Now, what I hope for, that once I look at their all X's and their all Y's, I would have known by then, since I measured all the 100, the average value of X and the average value of Y. In other words, I would have known that almost 80% of them or more happen to have the value 3, for example, in terms of X, and happens to have the value of 157 in terms of Y. That's good, but that's not the case. I'm not able always to pick up those 100 and try to figure this out. So what I hope for, to find one of those guys by complete chance. And once I measure his X, this guy in particular, right, happens to be 3, and his Y happens to be 157, which are exactly typical to those big findings on the entire 100. Now, this guy, it's called representative. Why is representative? Because you can see he represented this typical of a class or the group where he come from. And as a conclusion, without going through this hardship of finding 100 reading on all of them, will I be able really to say, I picked up a representative, these reading represent the average, so I can come up to a generalized idea that the average reading of X for this population happens to be 3, and the average reading of Y happens to be 157. Could I do that? Now, it seems the answer to be no. It's almost not possible to do that. the chance is 1 over 100. It's quite difficult to do so. What can I do alternative is to go complete randomly and pick this guy and see his reading. I pick another guy. Maybe instead of reading the 100, because it's quite expensive to do that, I could read maybe 10, 13. And after you get their 13 readings, you could come up with the conclusion, well, this is the average of X and Y that I found. This mechanism or this visual way of understanding what is going on is very crucial for two important fields of study. The research, which we are discussing at the moment, and also for the analysis part, which is coming in the next book. But for now, I just wanted to share with you a mental image, a picture of understanding the concept. And that's starting with what's so-called representative, which is later on will be translated as sampling from population and etc. Let me go back to the example that we have taken in the previous outline, discussion on descriptive. To remind you, the example was that we have the aim to answer this question. So we saw 3 T steps of transformation to describe this community, and we were able to provide an answer. Now, this selection of this group of people, are they the big circle themselves? Are they really the entire population that I'm looking at? Well, if it happens to be, then that's it. What I can say, whatever you reach out to an answer from objective perspective, it will be perfectly okay because you have handled the entire population. So your answer is straightforward. But that's in the case always to happen. Actually, the population is something like that. It's large, it's huge. And the image we were seeing before when we discussed the descriptive, that we have selected just a sample group, just like one of them, like one element of the big circle we saw in the earlier example. And we took it and we did the 3 T's, a transformation on them. And we come up with an objective answer to the research question. But is this enough, whatever we have reached out to say this answer, it is solid answer to the entire population? Well, I don't think so. So what the best to do, try to go and pick another group, take this group out, and once again do the 3 T transformation and come up with another answer. And one more time, I would have a lot of those objective final answers to this question. And the average of all those answers will give me a strong final kind of conclusion, if you are will, about this community in general. What is this? This is the image of inferential. So I hope now the visual representation of inferential is quite clear to you. This is the art of inferential and generalization. That is what is inferential and generalization is all about. Now, academically speaking, descriptive, which we have discussed in the previous outline, it summarized the characteristic. We saw the transformation to numerical and then to graphical. So it is the summary of characteristic of data. On the other hand, inferential, it allows you to test hypotheses or assess actually whether or not your data is generalizable, like we said down here, to a broader population. So we have come to the end of section 2 on the philosophy of descriptive and inferential. And this is the time we're gonna cover the last section of chapter 1, and that is to discuss the research conductor and categories. I will see you then.